So imagine you have this incredibly lush, vibrant garden in your backyard. The flowers are blooming, the soil is super rich. But someone, without telling you, secretly goes down to the basement and turns off the underground irrigation system.
Oh, wow. Just completely shuts off the water supply.
Exactly. And on the surface, things look fine for a little while, but underneath, the soil is quietly drying out. The structural integrity of the earth is degrading.
Right.
Eventually, the surface cracks, everything turns friable, and no amount of surface level watering is going to fix the fact that the fundamental life support system has just been shut down.
Yeah, it's basically a systemic failure masquerading as a localized problem. The infrastructure itself has collapsed.
Which is exactly the kind of complex biological landscape we are exploring today. So welcome to this custom deep dive.
Glad to be here diving into this stack of sources you provided.
Yeah, we have got a fascinating stack today. It includes head-to-head clinical trials, intense molecular biology studies on estrogen receptors, and really detailed breakdowns of platelet mechanics. And we are extracting the core cellular logic for you.
It is a dense stack, but the story it tells is incredible.
It really is. Our mission today is hyper-specific. We are answering, how does combining the O-shot with localized low-dose estriol cream enhance submucosal vascular endothelial growth factor expression?
Quite a mouthful.
Yeah, definitely a mouthful. But look, if you love understanding the actual biological hack behind regenerative medicine, this is where tissue engineering meets your DNA.
And to understand the elegance of that combination, we really have to look at the garden you just described.
Right.
In clinical terms, we are talking about genitourinary syndrome of menopause, or GSM. When systemic estrogen levels plummet during menopause, the genitourinary tissues, which are highly estrogen-dependent, they basically go into a state of structural starvation.
And the sources show the physical fallout of this, right? The epithelial cells lining the tissue, they lose their glycogen stores.
Yes, which leads to severe mucosal thinning.
But the absolute core of the issue, like the irrigation system of our garden, is the submucosal microvascular density. We're talking about the tiny capillary beds beneath the surface.
Exactly. When estrogen withdraws, those blood vessels don't just shrink, they actively regress and die off.
So the tissue is literally suffocating.
Yeah, it is. Without that microvascular network, there's no oxygen delivery, there's no nutrient exchange, and no immune cell trafficking. The extracellular matrix just begins to break down.
And this is what drives the severe drop in FSFI, the female sexual function index that we see in the literature. It manifests as chronic dryness, a complete loss of elasticity, and severe dyspareunia, which is painful intercourse.
The tissue becomes so thin and starved that it literally tears.
Right. So logically, to reverse this, we can't just apply a temporary lubricant. We have to rebuild the irrigation system from scratch.
We need new blood vessels.
Exactly. And the human body has a master biological switch for that, which is vascular endothelial growth factor, or VEGF.
Yeah, VEGF is arguably the most powerful angiogenic protein in the human body. When it's secreted into a tissue environment, it binds to receptors on the surviving endothelial cells, the cells that line the inside of blood vessels.
Right.
And it signals them to proliferate, secrete enzymes to dissolve the surrounding dead tissue, and physically migrate outward to form brand new capillary tubes.
It's basically sending out the construction crew.
Yes, exactly.
And the first half of the strategy to trigger this relies on an endogenous approach. We are trying to force the body's own internal machinery to start manufacturing this protein again, using localized low-dose estriol cream.
And the choice of estriol here, rather than, say, a stronger estrogen, like estriol, is highly intentional.
Oh, really? Why is that?
Well, estriol is a much weaker estrogen with a shorter receptor retention time. So when it's applied locally to the mucosa, it penetrates the cell membranes, but it doesn't cause the massive systemic spikes or that thick endometrial proliferation we associate with traditional hormone replacement therapy.
Okay, so it stays local.
Right, it stays local, but it is incredibly effective at the cellular level.
Yeah, I was reading through the molecular biology source you highlighted, and the actual mechanism of how it works is mind-blowing. The estriol molecule passes through the cell membrane and binds to estrogen receptors, specifically ER-alpha and ER-beta, that are just floating inside the cell cytoplasm.
Yep.
And they lock together to form this complex. And this is where it gets into pure biological programming.
Because that complex doesn't just sit there. It translocates directly into the nucleus of the cell.
Right, where your DNA is housed.
Exactly.
It acts like a targeted key. And here's where it gets really interesting. It scans the billions of base pairs of DNA until it finds a very specific regulatory sequence called a variant estrogen response element, or ERE.
Right.
And the source data notes this ERE is located exactly 1.5 kilobases upstream from the VEGF gene's transcriptional start site.
I mean, think about the precision of that. The DNA is a massive blueprint. The estriol receptor complex isn't just randomly throwing switches. It finds the exact regulatory control panel positioned just 1,500 base pairs before the actual genetic code for the VEGF protein begins.
That's crazy.
It is. By locking into that specific ERE, it forces the DNA to unspool and commands the cellular machinery to begin transcribing the VEGF gene.
So it's quite literally rewriting the daily operating instructions for that cell.
Yes.
And the data shows the outcome of this transcriptional activation. It's a 3.8-fold increase in VEGF production in the epithelial cells and a 3.2-fold increase in the underlying stromal cells.
And the estriol also hijacks a few other cellular pathways to amplify this signal.
Oh, like the slug VEGF axis mentioned in the sources.
Exactly. SLUG is essentially a transcription factor that normally regulates cell movement during embryonic development. Estriol actually reactivates it in this adult tissue to synergize with VEGF.
So preventing the endothelial cells from dying and helping them sprout outward.
We got it.
The data also points to something called PAF-mediated NF-kappa B activation. Now, NF-kappa B is heavily involved in inflammatory responses, which honestly sounds like a bad thing. Why do we want to activate an inflammatory pathway in already irritated tissue?
I know, it seems completely counterintuitive, but angiogenesis, the building of new blood vessels, is actually a controlled inflammatory process.
Oh, I see.
Yeah, you need a localized, highly managed inflammatory spark to tell the body, hey, there's a wound here, send resources.
Okay, that makes sense.
The estriol uses platelet activating factor, or PAF, to remove the inhibitor from NF-kappa B, allowing it to enter the nucleus and turn on survival and angiogenic genes. It's using a microscopic controlled stress response to trigger healing.
Okay, wait, I have to stop and challenge this for a second. Let's unpack this. We are looking at a 3.8-fold increase in VEGF. That is nearly a 400% boost in the master protein for building blood vessels.
Right.
Driven directly by cellular DNA. So if estriol is already boosting our natural VEGF production by nearly 400%, why do we need anything else? I mean, why not just use the cream and call it a day?
That is the big question, and it comes down to the condition of the biological factory you were trying to stimulate.
Okay.
You are sending a massive order for new materials to a factory that has been shut down, starved of resources, and literally rusting for years.
So the DNA might be screaming build, but the machinery is just sluggish?
Exactly that.
Right.
Because estrogen relies on the body's existing, aging cellular factory to start manufacturing VEGF from scratch. And transcription takes time.
Right.
The DNA has to be read, the messenger RNA has to be processed and sent to the ribosomes, the VEGF protein has to be synthesized, folded properly, and finally secreted into the extracellular space.
That's a lot of steps.
It is, and even then, the surrounding tissue matrix is still degraded and friable. The environment itself is hostile to new growth. So relying solely on the endogenous pathway is a very slow climb out of a very deep hole.
So if the factory is too slow to produce the building blocks, we basically have to physically parachute those building blocks into the tissue ourselves.
Precisely. What if we could bypass the factory and deliver the final product directly?
Which shifts us from the endogenous approach to the exogenous approach. Enter the O-shot, which is all about direct growth factor delivery.
Right, and this utilizes platelet-rich plasma, or PRP, which operates completely independent of any hormone receptors or DNA transcription delays.
The clinical preparation for this is fascinating. From the sources, you basically start with a standard blood draw from the patient's arm. That whole blood goes into a specialized centrifuge. And the physics of the spin is really what matters here, right?
Yeah. By applying very specific G-forces, the heavier components, so the red and white blood cells, they're forced to the bottom of the tube. What you are left with at the top is this golden layer of plasma, suspended within which is a massive concentration of the patient's own platelets.
And most people only think of platelets in the context of scabs. Like you get a cut, platelets clump together, and they stop the bleeding.
Right, but their structural role is far more advanced than just that. Packed inside every single platelet are dozens of tiny vesicles called alpha granules.
And what exactly is inside those granules?
They are heavily guarded payloads of folded, fully formed, active healing proteins. When we extract them via the centrifuge, we are isolating the body's premier first responder units.
If estriol is sending a memo to the factory manager to start hiring workers, the O-Shot is dropping off a busload of highly trained builders and all their supplies right at the construction site.
That is the perfect analogy.
So we take this super concentrated golden plasma, and it is carefully injected back into the sub-mucosal tissue of the vaginal wall and the clitoris. The moment that liquid hits the tissue matrix, what is the trigger? Do they just automatically open?
Well, the physical active injection, the contact with the surrounding collagen matrix, and sometimes the addition of a chemical activator like calcium chloride, it causes the platelets to degranulate.
They just burst.
They literally burst open. In a fraction of a second, they dump their entire payload directly into the starved tissue.
So we are talking about an immediate flood of exogenous VEGF, just bypassing the slow DNA factory entirely, along with platelet-derived growth factor, transforming growth factor beta, and epidermal growth factor.
And this is where we see a rapid shift in the extracellular matrix. One of the key actions of this payload is forcing the immediate deposition of collagen type 3.
Why type 3 specifically? Because there are, a lot of different collagens in the body.
Yeah, there are. Type I collagen is the thick, mature, rigid stuff. Think of mature bone or tendons.
Okay.
But type 3 is the early-stage rapid response collagen. It forms a flexible reticular mesh. The growth factors from the PRP immediately signal the local fibroblasts to lay down this type 3 net.
Okay, so it creates the physical scaffolding.
Right, the structural scaffolding that new blood vessels actually need to anchor onto as they grow. You can't just sprout a blood vessel into empty space, you know? It needs a trellis. The PRP provides both the seeds and the trellis instantly.
Wow. And the clinical trial data backing up this mechanical approach is striking. The sources outline a 90-woman clinical trial. These are postmenopausal women, aged 50 to 65, all dealing with the severe microvascular decline we talked about.
Yes.
And they split them up. One group gets 3 monthly PRP sessions. The other group uses the vaginal estriol cream for 12 weeks. They're literally pitting the exogenous parachute drop against the endogenous DNA factory.
And the results are fascinating. Both treatments successfully improved the vaginal health index, restoring fluid volume and epithelial integrity, and both drove up the FSFI sexual function scores.
Right.
But the POP group actually achieved a slightly higher mean increase in their function index. It was a jump of 10.1 points compared to 9.3 points for the hormone group.
Okay, let's look critically at that 0.8-point difference. In the grand scheme of clinical trials, is 0.8 on a subjective index actually a significant victory? Does the patient even notice that?
Statistically, the difference is marginal, but biologically, that 0.8 difference is monumental.
Really? How so?
Because it proves that the 10.1-point jump was achieved entirely without activating a single estrogen receptor. The PRP forced the tissue to rebuild its microvascular density and extracellular matrix solely through mechanical exogenous growth factor delivery.
Oh, wow.
Yeah. It highlights that the direct delivery of VEGF and collagen type 3 triggers neoangiogenesis so aggressively that it can outpace a 12-week hormonal intervention.
Which finally brings us to the core mission of this deep dive. If estriol works by rewriting the DNA instructions, and PRP works by dropping off the finished supplies instantly, how does combining them actually enhance the overall VEGF expression?
Right.
Do they just stack on top of each other, or do they interact?
They interact sequentially.
Right.
They fill in each other's biological gaps to create a continuous loop of regeneration. Think of it as an ultimate two-pronged biological attack, the immediate flood and the sustained engine.
Okay, let's trace the timeline on this. Prong 1, day 0, you administer the O-Shot. Instantly, the bursting alpha granules flood the starved mucosa with exogenous VEGF and PDGF.
And because the tissue's microvascular density is so low, this massive spike acts as an instant catalyst. It shocks the surviving endothelial cells right out of dormancy.
Right.
They immediately begin secreting proteases, dissolving the old rigid matrix, and utilizing the new collagen type 3 mesh to sprout new capillary tubes. It basically provides the immediate jumpstart the dead battery needs.
But there is a biological limitation to that jumpstart, right? Because those growth factors we injected, they have a half-life. They don't stick around forever.
Exactly. After a few days or weeks, they degrade and are metabolized by the body. If nothing else happens, the new vessels lose their signal, and they will eventually regress right back to where they started.
Which is precisely where prong 2 takes over.
Yes.
While the PRP is providing the immediate building blocks, the patient is actively using the localized low-dose estriol cream. And the estriol is quietly penetrating the cells, binding to the ER alpha and ER beta receptors, translocating to the nucleus, and finding that spot 1.5 kilobases upstream on the DNA.
It's turning the factory lights back on and hiring the workers.
Exactly.
And because transcription takes time, it perfectly mirrors the degradation of the PRP.
Huh.
Just as the exogenous growth factors from the O-shot are being consumed and fading away, the body's native DNA factory is finally fully ramped up.
Oh, that timing is incredible.
Right. The tissue's own native cells are now continuously churning out endogenous VEGF.
So the synergy really is unparalleled. The O-shot forces the rapid creation of the new microvascular network and the flexible scaffolding, and then the estriol ensures there is a sustained, permanent signal to maintain, nourish, and mature those newly formed vessels.
It prevents the regression.
Yep.
You are tackling tissue degeneration from two completely independent biological pathways.
Yeah.
The PRP bypasses the damaged system to provide immediate structural relief, which correlates clinically with faster resolution of pain and dryness. Meanwhile, the estriol corrects the underlying endocrine deficiency at the genetic level, ensuring the long-term cellular health of the new tissue.
You aren't just putting a Band-Aid on a symptom here. You are forcing the microenvironment of the tissue to revert to a premenopausal, highly vascularized state, and then literally rewriting the local code so it stays that way.
And when you dissect the specific molecular mechanics like this, it becomes so clear that combining these therapies isn't just, throwing two treatments at a wall to see what sticks.
Right, it's not guesswork.
Exactly. It is a highly calculated biological strategy designed to exploit the timing of cellular transcription and growth factor degradation.
And for you listening, this is exactly the value of unpacking these dense medical mechanics. It completely cuts through the marketing noise.
It really does.
You don't have to rely on vague promises of rejuvenation or whatever. You can actually visualize the cellular logic. You know exactly how the estriol binds 1,500 base pairs upstream to command the DNA. You know why the platelets degranulate to lay down a collagen type 3 net.
Yes.
You understand the why and the how behind this ultimate biological hack.
And as we wrap up, I want to leave you with one final implication to consider, scaling up from what we've discussed today.
Okay, let's hear it.
We have mapped out how combining transcriptional hormone activation with direct autologous growth factor delivery, meaning using the body's own extracted cells, can completely resurrect a dying vascular network in this specific mucosal tissue.
Right.
If we can master this dual pathway synergy here, could we eventually apply this exact same localized two-pronged logic to reverse ischemic vascular aging in the heart, or even stimulate microvascular repair in the brain?
Wow. That is the kind of biological horizon that really changes everything. We started today looking at a garden where the irrigation had completely dried up. We didn't just find a way to instantly flood it with water. We found the precise genetic control panel to rewrite the code so the rain never stops falling. Thanks for going depth with us.